Please reply yes in the chat if you can hear me. Okay. So today we are going to continue our problem solving sessions. This is week 9 of the Natural Language Processing NPTEL course. The instructor is Professor Pawan Goyal. Course code is NOC 22CS98, and I am Punyajoy Saha. Will be the teaching assistant for this session. Okay. So this week we are primarily focusing on topic modeling. So in brief, topic modeling provides methods for automatically organizing, understanding, searching, and summarizing large database of documents without any prior annotation. So the primary use cases are that it is used to discover the hidden themes that pervade the collection. We can annotate the documents according to the found themes that we have got, and use annotations to organize, summarize, and search the text. Let's move on to the first question. So this is a very easy one. So LDA topic modeling is then you have different options: supervised learning, semi-supervised, unsupervised, or reinforcement. So what do you think the answer of this question will be? Can you tell? So what are these different types of learning? What is supervised learning? Yeah, unsupervised. So that is the correct option. Then the second question is, which linguistic phenomena can cause the same word to be active in different topics? So out of this, which one is the correct one? Okay, so the third one is the correct one. So the way the model is defined, it is not that mutually exclusivity is maintained. So it means that it does not restrict words to be part of only one topic. For example, both money and river topics can give high probability to word bank. This is one example where this kind of thing can happen. Okay, now the next one is, for the following graphical model, you have to write the correct factorization for the joint probability distribution over the random variables. And here alpha is hyperparameter chosen manually, so it is not a random variable. So how do you do this? So the basic idea of doing this is that we have to check the dependence relationships. So for example, beta is directly dependent on the alpha, so you can write that p beta given alpha. Then we write a x1 term for the next ones. Then we see that there is a summation or a sequence from 1 to n. So you have to take the product of the whatever probabilities is calculated here. And how this probability will be calculated? So this is wn into probability of wn and xn. So wn is again dependent on beta, and xn is dependent on both beta and wn. So the final output will be beta probability of beta given alpha and product of 1 to n, p of wi given beta and p of xi given wi comma beta. This is the way you can resolve any graphical model. So the only thing to remember here is that the dependence relationship is only till the last previous step. Not so xn is not dependent on alpha. So those things we are not considering. Any doubts over this question? Okay. Yeah, so this is the correct option. So which family of distributions, the next question is, which family of distributions can be used to parameterize a probability distribution over uh, in a discrete sample space? So for a discrete sample space, which is the correct way to parameterize a probability distribution? This is again directly from the lectures. So this will be the Dirichlet distribution. Next is, which family of distributions can be used to parameterize a probability distribution over. Sorry, this one is the. Oh, I think the question is mistaken once. Yeah, so the correct. Yeah, the correct question is this: which one of the following is latent random variable? So again, if you follow the lectures, you will. Yeah, so here the Dirichlet prior parameters are alpha and n, which are hyperparameters and are non-random variables, and beta is the latent random variable, and z is also a latent random. Yeah, so this is interesting. So in an LDA model, if you increase the value of alpha from alpha less than 1 to alpha more than 1 for the Dirichlet distribution over the topic distribution, which sort of topic distribution will become more probable? So what will be the answer to this? So remember alpha that we are using to um, that is the hyperparameter here. So how does changing alpha actually impacts the performance? Does anyone know? How does changing alpha actually matters? So let us see the examples given in the lecture. So this is for alpha is equal to 1. Okay. So alpha is equal to 1. You can see some of the probabilities getting higher values. As we go to 10, those higher values are reducing. And 100 is almost like very like almost uniform. And if you check for alpha less than 1, you can see that some probability values are again high and others are very, very less. So according to this, this topic, P single topic with high probability, is less than P of more uniform mixtures of many topics. This is true. And P of very high few topics with high probability is less than P of more uniform mixture. So these two are true. Yeah. So next is, which of the following are the disadvantages of the LDA model? Yeah, 2 is fine. Other than that, cannot capture. 2 is for this question or the previous one? Okay. Yeah, 2 and 3 are the correct option. So what will be the disadvantages of the LDA model? What is the disadvantage of the LDA model? So first one is number of topics has to be specified. So this is true. This is a disadvantage because You cannot just run LDA without any number of topics. You have to set them. Cannot capture correlation between topics. This is also true. It assumes a bag of words assumption, so sentence structure is not is ignored. So given a sentence or different forms of sentence, it will be considered the same given the bag of words assumption. And finally, it cannot model topic dynamics in like long periods of time. So these all four are the limitations of the LT. And finally, after which one of them following is true about SLTA? So SLTA is the supervised version of the LTA here. So here, along with the the LTA, you have some specified keywords from the classes as well. So this specified keywords can act as an observed random variable. That is the target class. So that is given in the second answer. The response variable can be treated as an important observation to infer the topic probabilities in a supervised manner. So this is what is different in supervised LT. Okay, that this part is still what the questions were. So do you have any questions overall? This was very easy assignment. So now we'll move a bit to the like coding topic modeling algorithm in like with Python. So because these are very very easy. So if you have any questions, you can ask. I'm waiting for 5 minutes, and after that, I'll move to the coding part. Okay, let us move to the coding part. So here, so this is very interesting. So let us. So we are trying to topic model on the research paper in NeurIPS conference. So our whole idea is that given a bunch of conference papers, can we identify key themes or topics? This is a very realistic setting. So usually there are many papers in the conference. You want to know what are the key, what are the key themes present in the conference. So let us see how it is done. This part is like download. Then we are loading the. So yeah, so there are 1740 papers. So this is our entire document set. And if you see some of the papers, let's say, this is paper zeros first 1000 elements. Then we will do some very trivial text processing. So we will remove the stopwords, then tokenize it, and finally use a limiter. So these things are not that important, but can check them. And here we are trying to we are tokenizing all the papers and adding this to the norm papers list. So we will see what is happening in the norm papers. Yeah. So if you see the norm papers, it will return a list of words that do not belong to the stopwords list. And we have also removed anything like numeric. So these are generally like the results in a paper. They remove that. After that, uh, this distribution is good. Okay. Now let us move to the LDA part. Yeah, so LDA, for LDA we are using the mallet library. Yeah, so we will use the LDA model from here. So here we have to provide the bag of words corpus. So bag of words corpus. Yeah, so here we are trying to create a bag of words corpus. So what it does is it creates a list of, so it will create a list of words and how many times the word is getting repeated. And this elements here like 7, 18, these represent the word ID. So this we have we have run this bigram model and then generated this bag of words letter. So here we are filtering out the words less than 20 documents because they might not represent the themes, or more than 60%. So this 20 documents is because they will not represent a theme, and 60% because they will be present in each of the topics. So both are not important for us. Yes, I will share the link after the session. Yeah, so see, there are sample word to number mapping. So for example, zero word is 2e. The 2e can be present like in 2e to the minus 5 or something. Then ability, able, Abraham, etc. are present. And the total vocabulary size is around 78,000 words. And there are bigrams as well, like ad hoc. So bigrams are identified by this underscore that is present. Now we are running this. So if you run this, the remaining is 7756. So this dictionary, whatever is there, if I print it, now you can see many of the words previously got removed. Dictionary items. Let us see what I. Yeah, this all words are there. Yeah, so basically we're removing some of the frequently occurring. The final size of dictionary is, vocabulary is around 8,000. Yeah. Next we move to this part. So we are transforming it to a bag of words corpus, and we can also see what is happening here. So it is showing that for bag of corpus 1, that is the first document, what are the dictionary ideas and their frequency. So account is occurring 1, advantage is occurring 4 times, although is occurring. And finally, if you check, the number of papers are 1740, same as before. Now we move to the LDA part. As I am not doing the algorithm specifically because this is already taught in class. So let us try to run it. So it will take some time. in that case, let's try to understand the parameters. So corpus is the bag of words corpus. So you have to create this corpus when you run anything, run the LD model. Then ID to word is a dictionary from ID to word mapping. Chunk size here is how many documents a process at once. So we have a very small set. So we are giving the entire set as a chunk size. Alpha is going to be set automatically. We do not need it. Similarly, eta also will be set automatically. We specify a random set so that we can reproduce the results. And finally, there are iterations. So when one pass, there will be 500 iterations. There are 20 passes overall for the entire set. And we are not having any eval set, so we are not evaluating. And finally, you have to provide the number of topics. So here we are specifying number of topics as 10. So you can give 20 as well. And let us try to see the topics. So yeah. The first topic is feature recognition, probability, word cluster, etc. Then there is this topic, that image object feature. Then we need to evaluate the topic model. So after doing this topic modeling, we need to know whether the topic modeling is good enough or not. So one thing is that we can do it manually by directly looking at the topics. But this is a difficult thing to justify why we are choosing something, because it is subjective nature. That's why we use this coherence score. The coherence score basically tells us the higher the coherence value is, the better the topics are. Yeah. So, and finally, we can tell what are the weights of different words in the topic. That is another thing. Yeah, so let us try to change the values. So our current coherence score is minus 1.09. So let us increase the number of topics 50. Let us see what happens. Let us see what happens if we increase the topic number of topics by 15. So what do you think will happen to the coherence score? Let's see what happens to the topic. Consider side change in the topics, the character, word, circuit, neuron, physical, and overall score is, yeah, is introduced. So when we are doing a topic modeling, we have to try with several this topic number of topics and then try to select the one with the highest score. Setting a topic too high like 100 will also not be very useful. And then we can use other coherence metrics as well.
পালাবো ওগুলো আমি দিলাম তো ইউরো
Yeah, so you can see that there are different coherence scores as well as model perplexity to measure it. Then we can also run a different library known as mallet for the same thing. Okay, till this runs, you can also see what is LDA tuning. This is actually finding the optimal number of topics. That's what I was talking about. So you start with the topic now and uh, go till some topic count and then try to see which one has the highest scores. This will be a for loop and where we are calculating the LDA model as well as the coherence score and then trying to see uh, and then we are trying to sort the coherence score. So if you see that for number of topics as 21, the coherence score is the highest. So this is the topic that will be. And finally, we can plot this number of topics as well. This will be a bit long process because it has to go to a lot of topics. So from starting topic count as 2, which is the minimum, to end topic at 30. And this will take, I think, a lot of time. And then you can check the topic. Okay, I think there's still this much is enough. So I will share the collab notebook link in the NPTEL slides as I share them. As usual, the slides and the videos will be uploaded here. Thank you for joining. Do you have any questions?